if you had 14 births, the probability of getting no girls, very remote, not exactly zero, but close. One girl, pretty small, two girls, pretty small, and so on. Then when you get around the 50-50 mark, it's around 0.21, which is a little bit more respectable. But then you start declining again afterwards. Whereas, if you rationalize this one in your mind, it's like 14 births giving 14 girls. So you're working in the hospital, you go into the nursery, you just found out that 14 moms gave birth last night. And you walk in and you see 14 pink blankets. And you're like, holy crap, really? Every single one of them girls? That's shocking. Like, you weren't expecting that. You thought maybe there'd be a boy in there somewhere, right? So it's something you're not expecting. Not impossible, not an outlier, because it is conceivable, but it's not something you saw coming, right? Now, you say that there's 11 girls and 3 boys. You're less shocked. 7 and 7, you're like, oh, 50-50 split. Oh, that's interesting. But you're not surprised by that, right? It's when you have the extremes that you start getting more and more surprised. So what I need from this is the mean and the standard deviation. So plugging and chugging. And my little shortcut on the previous page, it really doesn't play any role here, stat edit, because they're not all the same values in P of X, so we're just stuck. Okay, I flubbed something up. I think it was in the first column. I felt like I missed something. Four. Okay. Well, I'm going to insert second, delete on the 5, and change the 0 to a 4. All better. All right, so you get your data in. Stat, calc, 1. Actually, I think we're done. Let me just look real quick. I think we're done with the rest of this list. Let me just scroll through it real quick. Yeah. So for the remainder of the course, the only thing we're looking at in the calc menu is option 1. So that should help. I mean, unless you have to take the final, in which case everything's fair game. But let's not think about that. I shouldn't have even brought it up. So list 1, list 2. Calculate. All right. That was nice. All right, so I kind of expected, like in the situation, I sort of expected if there were 14 births, roughly a 50-50 split. So that feels right, a mean of 7. And then the sigma 1.875. I had no sense of that, but I did kind of expect this. So that was a value I expected. Not out of the realm of possibility, certainly. But you know, if you walked into 10 different hospitals and into their nurseries, and in each case there was an equal number of boys and girls, you know, 5 boys, 5 girls in this hospital, 10 girls, 10 boys in this hospital, and so on. After you get through enough hospitals like that, then expected starts becoming unexpected. Like, wait a minute, that's even weird now. You know, numbers, they're just how they play out. They should have some variation to them just by virtue of life, right? So in terms of the distribution, well, we can go about it one of 2 ways. We can go through the empirical rule, which I know we all like doing. That was a joke. I know it's kind of hit or miss as to whether or not people even remember it at this point. But if you do, it's the 68, 95, 99.7 rule. The issue with that is it says what kind of distribution it is it? Well, that's only going to tell us whether or not it's a normal distribution. If it's some other kind of distribution, then I'm still going to be at a loss. So what I'm going to do is I'm going to take a look at the graph. So second y equals, I'm going to put my plot 1 on. Right. And you could pretty much choose your type here, except for a scatter plot. Histogram will do the job. If you want to go box plot, you can do that too. I'll do a histogram. And let me actually snip that. Oh, I didn't hit any zooms. And I also have an equation in here for some other class, which is not mine. Zoom stats, so zoom 9. All right, well, doesn't look very normal. But also, I let the calculator decide on the settings. So we go into the window and make sure it's the way we want it. 0 to 16.8, probably a little overkill, maybe 0 to 15, even 14 if you want. The scale for X, well, they're only going by 1s here, so why on earth I'd go by 2.8? I don't know, so let me go by 1s. Y min, Y max, I don't know until I try. So let me get this in here. I suspect it's probably pretty close to what it needs to be, but it may need some tweaking. Interesting. So it looks like a uniform distribution, so obviously I messed something up. I did. Can anybody see what I messed up? Yeah, I did. The frequency, yeah, I still have it in as 1. That's got to be L2. All right. The keywords in the problem, it's not a uniform distribution, and what came up on my screen, a uniform distribution, so strike 1. And then also, just even if it didn't say that, these numbers don't look like it should be a flat line. So let's try that again using a technique I like to call the right way. Zoom 9. Oh, that's even better. Look at that. Whew. All right, so 0 to 20. Again, I don't need that. I'll go 0 to 15. I'm not going by 14s. That's just stupid. Go by 1s. And hit graph, see what we're looking at. Oh, look at that. Yeah, a little nicer. And I don't even need to move in closer on this because it gets the job done. I mean, we're not asked to prove anything here, but you know, anytime you prove something, it's probably not the worst idea in the world. But let me get rid of these because I got to put the right ones in. But I think this is pretty convincing that what we're looking at is a normal distribution. I mean, it's the kind of thing, like if I were teaching normal distributions for the first time by creating a frequency histogram, that's probably what I would draw. Something like that, or at least try to, and it wouldn't even look that nice. So we're in good shape there. And the best news about this, I think, is that you already know how to do all this stuff. This is all Unit 1. And it was like one of the easier parts of Unit 1. What else did I have? I think. Oh, my settings. Okay. Yeah, let me just get that in there too. If I'm snipping, I might as well snip, you know. But we're going to learn how to apply different context to this, which is going to make it more meaningful. Right? But what I want to do, again, as a follow-up, is to determine if 13 girls among 14 births is unusual. Right? So I need to figure out mu plus or minus 2 sigma. So 7 plus or minus 2 times 1.875 approximately. It's just calculator work. So you get these two entries. All right, so this is the usual range, 3.25 to 10.75. Usual. So therefore, 3 dots in the form of a triangle means therefore 13 is unusual. Not inside the interval. Sorry, what page? 36. Questions were